Dear students, welcome to my YouTube channel PCM Academy. Now let us discuss the previous year questions based on IIT Jam Physics. In the last class we have discussed 4 questions. Now let us continue our discussion from question number 5. Okay. So the question is that EFGH is a thin square plate of uniform density sigma and side 4a. 4 point masses each of mass m are placed on the plate as shown in figure. In the moment of inertia matrix I of the composite system, option A, only Ixy is correct, is 0. Option B, only Ixz and Iyz is 0. Option C, all the product of inertia terms are 0. And option D, none of the product of inertia terms is 0. So from the options you can see that they talk about only product of inertia term. But you know, in moment of inertia tensor there is 9 terms, out of 3 terms are principal moment of inertia and 6 are the product of inertia. So here we have to find out only the product of inertia. So let us give you the solution. So you know from the definition that moment of inertia, the product of inertia Ixy, that can be equal to Ixyx also, and this is nothing but minus summation mi yixi. And if you talk about yxz, that is same as izx, that is equal to minus summation mi zi xi. And if you talk about I yz, so that will be I zy, and that will be minus summation mi zi yi. Now you can see there are 4 masses. From this figure you can see there are 4 masses, and the coordinates of each and every mass is also given. But in the coordinates you can see that the z coordinate is 0 for each masses, because here is minus a comma 0. Let us take this as a first, then second is minus a comma 0, third is a comma minus a comma 0, and fourth is a comma 0. So now a z component is 0 for each and every mass. So if you substitute or if you open this summation involving zi, so you will get z in each and every terms, and that will give you 0, because this is always a multiplication with xi and yi, so that will be 0. But if you see here, so for 4 masses, if you open this summation, you will get for the first mass it will be m into yixi is minus a into minus a, that will be minus a square, plus m into here minus a into minus a means a square, plus m into a into minus a, it is again minus a square, and plus m into a, that is a square. Now you can see this m minus a square and m square will be cancelled out, again m minus a square, m square will be cancelled out, so it will also be 0. So ultimately you can see all the product of inertia terms are 0. So option C will be correct. Okay. Now let us move to the next question. Question number 6. This question is also asked in IIT Jam 2008. A circular disc in the horizontal xy plane is spinning about a vertical axis through its center O with a constant angular velocity omega. As viewed from the reference frame of the disc, a particle is observed to execute uniform circular motion in the anticlockwise sense centered at P. When the particle is at the point Q, which of the following figures correctly represents the direction of the Coriolis force and the centrifugal force? Okay. So let us choose a coordinate system first. Okay. Suppose at this point Q, and here this disc is rotating in the horizontal plane xy plane and is spinning about a vertical axis through its center O with a constant angular velocity omega. That means it is spinning along this direction. Okay, along this direction, suppose. Okay, so if your omega is in anticlockwise direction, then obviously the angular velocity vector omega will be perpendicular to this plane. So omega will be perpendicular to this xy plane, because that disc is rotating on xy plane. So omega can be written as omega k cap. Okay. And if you talk about r vector, so with respect to point Q. So if we take this as our x axis and this as our y axis, so the velocity at this point Q will be in this direction, because this is our circle actually. So if we take this as our circle, so obviously this is along y direction, negative y direction, that is minus j cap. So if you talk about v vector, then that will be minus v j cap. So what will be your Coriolis force? You know the expression of Coriolis force, F Coriolis, that is nothing but minus 2m omega cross v. Omega cross v. So here omega is what, k cap, and v is minus j cap. So k cross minus j cap, and you know k cross j is minus I, and this minus I will be plus I cap, and with this minus I. So there will be 3 minus sign actually. Why? You know k cross j is minus I, and 1 minus sign is here, so that will be plus I, and 1 minus sign is in the expression, so it will be minus I cap. So this is along negative x axis, that means along this direction, and that is represented by figure A. Okay, and you can see centrifugal force is always away from the center. So centrifugal force will always be away from the center along this direction, and Coriolis force is also in the direction of minus I cap. So obviously option A is correct. Option A is correct. Okay, now let us move to the next question. A space crew has a life support system that can last only for 1000 hours. What minimum speed would be required for safe travel of the crew between two space stations separated by a fixed distance of 1.08 into 10 to the power 12 km? So L0 is given, the proper length or the proper distance L0 is given, that is 1.08 into 10 to the power 12 km, that is into 10 to the power 3 meter. This is given here. And what minimum speed would be required for safe travel? So what will be the speed, minimum speed v? So if minimum speed is v and here time is t, so vt will be L. Okay, and we have to find out v, and t is 1000 hours, that means 1000 into this second. So we can convert it from hour to second by multiplying 3600. Okay, now you know the relation between L and N naught, that is nothing but L is equal to N naught divided root over 1 minus v square by c square. Now what is L here? L is v into 1000 into 3600 is equal to N naught, means 1.08 into 10 to the power 15 actually, root over 1 minus v square by c square. Okay, now if you solve it, you will get v from here. Okay, now you can see that here is 10 to the power 15 here. So if you solve it, you will get just this is v is equal to, if you cancel these terms properly, then you will get 3 into 10 to the power 8 actually into root over 1 minus v square by c square. Okay, so this 3 into 10 to the power 8 can be replaced by c, so it will be v is equal to c root over 1 minus v square by c square. That means your 1 minus v square by c square is equal to v by c, and if you square, it will be v square upon c square. So your 1 will be 2 v square upon c square, that means your v square upon c square will be half. So v by c is equal to 1 by root 2, so v is equal to c by root 2. Okay, so just calculate this, you will get 3 into 10 to the power 8. So your option, correct option will be option B. Okay, now let us move to the next question. A particle is moving in space with O as the origin. Some possible expression for its position, velocity and acceleration in cylindrical coordinate system. Okay, so you should remember this result for cylindrical coordinate and plane polar coordinate at least, but if you want, you can also remember the result of spherical polar coordinate also. But according to JAM syllabus, the expression of position, velocity and acceleration you should remember for at least for plane polar coordinate system at least for plane polar coordinates, because the derivation is large, you don't need to do all the time. So plane polar coordinate and cylindrical coordinate, at least you have to remember these two. Cylindrical. Okay. So for plane polar coordinate, the position is actually position vector r is equal to actually r cap plus theta cap. So here, because this is the position r theta and here is actually rho phi z. So here your position vector will be just rho, in terms of rho, there is rho cap plus phi cap plus z cap. Okay. And here if you talk about the velocity, that is r dot, actually that will be r dot r cap plus r theta dot theta cap. That means actually dr upon dt into r cap, r dot is actually means dr upon dt plus r into d theta upon dt theta cap. Similarly here if you talk about r dot, that is velocity, actually that means velocity. Okay. So this will be just rho dot rho cap plus rho phi dot phi cap plus z dot z cap. So this term is extra here. So there will be d rho upon dt rho cap plus r into, so this will be not cap, r phi dot phi cap. So d phi upon dt 0 phi dot plus dz upon dt into z cap. Okay. So you can see this result and this result. Okay. So according to this, option A is correct. Okay. So this is how you can remember at least these two result, plane polar and cylindrical coordinate. But if you can remember the result for spherical coordinate also, then it will be more better. For spherical coordinate also you should remember, but at least these two you should remember, because if you know plane polar coordinate system, just add the z component. Okay, simply z component. For position it is z, for velocity it is z dot, and for acceleration it is z double dot. Okay. So thank you. We will discuss the more questions in the next class. Okay.